A circle is the set of all points that is an equal distance from a set point. Okay? You have a set point, a dot. And we talk about locus of points. A locus or a set of points that is the same distance from this dot would always be a circle. All the points that are 5 inches, all the points that are 10 inches from this circle, all the points that are 10 feet from this point would be a circle. Okay? All the points in all directions. So the locus of points. What we're going to be doing today is finding equations of circles. Okay? And let's not start out there. Let's start out here. Let's graph something. Let's graph x squared plus y squared equals 9. In order to graph this, now you could try to get x or y by itself. Okay, actually, let's change that. Let's do x squared plus y squared equals 25. It's going to be a little bit, that's going to give us some more points to work with. In order to graph this, here's what I would do. Well, first off, I'd give you some graph paper. If you don't have graph paper, you can just sketch a graph there. And let's make a t-table. This is not a line. Lines look like was index plus b. If you try to get y by itself here, you don't have just plain x. You have x squared stuff. You have y squared stuff. So here's what we're going to do. We're going to take and we're going to plug in some stuff. When making a t-table, you can graph anything with a t-table, even lines. We know shortcuts, but you can still use t-tables. Let's plug in some values. Let's say that x is equal to 0. So what that would do, that would scribble out this x squared, because 0 squared is 0, and it would simply leave me with y squared equals 25. So if I remember how to solve that, and how many solutions does it have? Somebody said it over here. How do you get rid of a square? And not just square root, but you also have to look at the positive and negative square root. Remember doing that? So you have two answers. So when x is 0, y could be 5, or y could be negative 5. And I tell you honestly, you never have to do a t-table again if you can go straight to here. 0, 5, and 0, negative 5. 1, 2, 3, 4, negative 5. Let's plug in a different value. I choose 3. Let me erase this up here. If x were 3, I'm going to plug it in right here. 3 to the second power, I now have 9 plus y squared equals 25. What do I have to do now? Good. We subtract 9 minus 9, and I now have y squared is 16. To get rid of a square, I square root. And not only square root, but don't forget about positive or negative. For this reason. Could y be 4? Yes. But what is negative 4 squared? Also 16. So y could be 4, y could be negative 4. So when x is 1, 2, 3, y is 1, 2, 3, 4. Or y could be 1, 2, 3, negative 4. Question now. Think about this one. Plug in negative 3. What happens? The same thing. When you square negative 3, you plug in negative 3 and you square it. Do you not get this exact same equation? So when x is negative 3, y is 4. And y is also negative 4. So negative 1, 2, 3, 1, 2, 3, 4. And negative 3, 1, 2, 3. Negative 4 is also a 4. Let's plug in 4. Let me erase some of these. Get us some, not that. Get us some more room. I've already got all those graphs. We don't need them anymore. Let's plug in 4. And we're not going to do them all like this. This is the hard way. When I plug in 4, I get 16 plus y squared equals 25. I subtract 16, I get y squared is 9. Megan, if y squared is 9, what is y? Square root you get, or it could be, good. So when x is 4, you get 3, or you could get 1, 2, negative 3. And reminder, if you plug in 4 or if you plug in negative 4, you get the same answer. So negative 4, 1, 2, 3, 4, 1, 2, 3, negative 4, 1, 2, negative 3. When you plug in negative 5, you get 0. If you plug in positive 5, you get 0. I think you're starting to get the idea. Let's plug in one other thing. Let's plug in 2 or 1. Let's try 2. Now this is not going to be as pretty. And that's the reason I waited till last to plug it in. When you plug in 2, you get 4. 4 plus y squared equals 25. Subtract 4, you get y squared is 21. We don't know anything that squares to give us 21. But to get rid of a square, we go to the other side and we do plus or minus the square root. Let's type that into the calculator for me. When x is 2, you get the square root of 21, which is 4.58. So about 4.6, or you could get negative 4.6. So when x is 2, you get 1, 2, 3, 4 and a half, 4.6, somewhere right in there. 1, 2, 3, 4.6. Same thing when you plug in negative 2. It's symmetrical. So you're going to get those values. Again, I believe you see what's happening. You have a circle. So, to make a long story short, y equals mx plus b was a line. X squared plus y squared equals, let's go back to that circle. If I connected my dots, and actually drew that circle, somebody tell me what the radius is. Remember radius? The radius is the distance from the center to the outside of the circle. What's the radius of this circle? 5. Is there a relationship between this number and 5? It's squared, isn't it? 5 times 5 gives you 25. So now, let's try that again. The basic equation of a circle is x squared plus y squared equals r squared. It looks a lot like Pythagorean theorem, and there's reasons for that, which we might talk about later. But anytime you have the equation x squared plus y squared equals r squared, you have a circle. And that's what it says on this next page. Man, that's a little bit deeper. We'll go into that later. So now, let's do this the easy way. If I ask you to graph x squared plus y squared equals 9, which is what we started to graph over there. That is a circle. X squared plus y squared equals some number. That will always be a circle. Now the question is, how big is the circle? This tells you how big the circle is. The 9 is not the radius. The 9 is in the place of r squared. So the radius squared is 9. What number could I put right here to give me 9? The radius is 3. This is a circle with a radius of 3. So again, if you need to come over to the side and say, well, r squared is 9, square root that, the radius is 3. Not positive negative 3, the radius can't be a negative. So if I ask you to graph this, let me show you the easy way. Start at the origin, travel 1, 2, 3 units to the right, travel 1, 2, 3 units up, left, and down, and simply draw a circle as best you can. Oops, that was bad. Try it again. Kind of looks like a football, but you get the idea. Okay, x squared plus y squared equals 9 is a circle with a radius of 3. Imagine if this were a circle, that's what it would look like. Okay, let's play around with this a little bit. I have here, I went online and I simply found a graphing calculator. And what's cool about this graphing calculator is it doesn't just graph y equals something. You can type in, like here, notice what I've done, x squared plus y squared equals 9. I get a circle, and the radius is 1, 2, 3. If I typed in x squared plus y squared equals, just a backspace, I don't want to have a backspace here. Let's try x squared plus y squared equals 16. See what happens. X squared plus y squared equals 169. That's a huge circle. Why is that not on my graph? How big is that circle? What's the radius? Close. 13. X squared plus y squared equals 169 would be a circle with a radius of 13. 13 times 13 is 169. Okay, let's go back. And let's change this circle some. And what I want you to note is what's happening. Instead of x squared plus y squared equals 16, let's do x, I don't know, plus 2. X squared plus y squared equals 16 was a circle with a radius of 4. This is still a circle with a radius of 4. But what happened? It moved, didn't it? How far did it move? -2. It moved 2 spots to the left. And I want you to see the relationship between the equation and how it moved. X plus 2 moved it two spaces to the left. Let's type in x plus 3. What happens? Moves it 3 spaces to the left. Let's type in x plus 5. Moved it 5 spaces to the left. Let's type in x plus 7. Moves it 7 spaces to the left. It's confusing because it's backwards. Because you would think pluses would move it right, but it doesn't. Pluses actually moves it left. So let's go back. And you already know what is about to happen. If I type in x minus 3, what happens? Moves it 3 spaces to the right. So we see now relationships here. Anytime you have numbers with the x's, you have pluses and minuses with that x, it's going to move it either left or right. If it were a plus 5, it'd move it left 5. If it was a minus 5, it'd move it right 5. So how are we going to move it up and down? You already know, don't you? Where do you put it? Where are we going to put numbers to move it up and down? On the y. Y. Let's go ahead and take that x minus 3 off. Let's just leave it as x. Now let's do y minus 1. Same circle, moved up 1. Y minus 3. Same circle, moved up 3. Y minus 5. Same circle, moved up 5. And we already know plus signs would move it actually down. So let's combine the two. And we have now the circle x minus 5 squared plus y plus 3 squared equals 16. That is a circle with a radius of 4. We always obtain our radius from the right side. This is r squared. That has been moved to the right 5 units and has been moved down 3 units. So how does that change my circle? How am I going to ask you how it moved? By what I'm about to say. X squared plus y squared equals 16 was a circle that had a center at 0, 0. Did y'all notice that when we first started, our circle centered around the origin? We moved our circle. We moved our circle right 5 spaces, and we moved our circle down 3 spaces. Our center is now where? Close. 5, -3. Right 5, down 3. So what you can do is this number right here tells you where the center of your circle is. Okay? If this was an x minus 2, that means my center moved right 2. If this was a y minus 6, that means my center moved up 6. And if I move it right 2 and up 6, my center is now at 2, 6. So to make a long story short, pretty much the opposite of this number and the opposite of this number tells you where the center of that circle is. Because minuses moves it right, pluses moves it left, minuses move it down, pluses moves it up. So now let's go back and work some of these problems. And that's where this comes from. The h and k in this formula, you don't have to write that. But the h and k, what I would rather you know is a circle is x squared plus y squared equals r squared. We can translate. Let's go ahead and write that word down, because we're fixing to have to talk about it anyway. We can translate a circle by adding pluses and minus signs to our x's and y's. A translation is one of your transformations. It's a transformation that slides the circle. So to translate or to slide the circle over, you're going to add pluses and minuses here and here. So here we go. X squared plus y squared equals 36. Caitlin, this will be a circle with a radius of what? Good. And the center of this circle is at 0, 0. Everybody understand that? Let me move it. X minus 5 squared plus y minus 2 squared equals 36. That is the same circle. The only difference is it's been moved over. See if that makes sense. Vanessa, minus 5. Does everybody know where the x-axis is, right? That's the way I remember it. X-axis runs left and right. So that minus 5, Vanessa, how's that going to move your circle? Good. To the right 5, is it not? And Vanessa, how's that minus 2 going to move? The y-axis runs up and down. So therefore, the y minus 2, how's that going to move your circle? Moves it up 2. My center is no longer at 0, 0. Take that center, move it to the right 5, and move it up 2. Can anybody tell me what my new center is? 5, 2. Right 5, that's a positive 5. Up 2, that's a positive 2. And again, you can simply obtain that by taking the opposite of this number. Take the opposite of this number. That's going to tell you where your center's at. Now let's work that backwards. Write the equation of a circle. Oh, that's easy. X squared plus y squared equals r squared. There's your basic equation. Write the equation of a circle that has a center at 1, negative 8. That center has been moved right 1, down 8. Try to do that for me, Hunter. Instead of x squared, we're going to have x plus and minus something squared. Instead of y squared, you're going to have y plus or minus something squared. Hunter, if I moved it right 1, what number right here would move it right 1? Negative 1. Opposite. Negatives move it right, positives move it left. And Hunter, to move it down 8, what would I put here? Add 8. X minus 1 squared plus y plus 8 squared equals, Erica, do you know what to put out here? Close. 7. This is r squared, right? So instead of 7, we're going to put a 49. That's the equation of a circle with a radius of 7 and a center of positive 1, negative 8. Now, how do I graph that? On your test, there's a good possibility that you're just going to be given, well, that's kind of, it's going to be hard to graph. You're going to be given this equation to say graph this. Here's how you do it. Well, first off, I'd use a different sheet of graph paper because it's going to be hard to fit it on this one. But just to let you know, here's your center, 1, negative 8. You have a radius of 7, so from that center you go 1, 2, 3, 4, 5, 6, right 7, 1, 2, 3, 4, 5, 6, left 7, up 1, 2, 3, 4, 5, 6, 7. And if you have a circle tool, you pick it and you draw a circle. You might have a circle tool built into the pencil. There you go. If anybody has a circle tool built into your pencil, you simply choose the circle and you draw a circle. There you go. Write the equation of each circle. This is ACT material, by the way. Circles are ACT material. They're on there. And they're easy. Once you learn how to do them, they're not bad. Kyle, all circles look like this. X squared plus y squared equals r squared. Kyle, I need a radius here. Can you get that for me? So we have part of our equation. Instead of r squared, we can now put 9. X squared plus y squared equals 9. But this is not your basic simple circle. It has been moved. It hasn't been moved left or right any. Here's your center. But it has been moved up 4. So Brianna, what I want you to do is take that x squared plus y squared equals 9 and shift that circle up 4 units, which is what we have here. And I now have x squared plus what, Brianna? How do I shift it up 4 units? Y Good. Equals 9. Guys, that's that circle. X squared, it did not shift left or right any. Plus y minus 4 squared, shifted up 4, equals 9, which tells me it has a radius of 3. A good ACT type problem, or actually a good math competition problem, is them giving you this and saying, what's the area of that circle? That'd be a good problem. Do you remember how to find the area of the circle? This is completely last chapter, next to last chapter, but because we don't get till area and perimeter and circumference and all that till later. Does anybody remember how to find the area of a circle? Area equals, if it has a pi in it. You know how easy it is to find the area from the equation? What is this? This is not the radius, right? Isn't that the radius squared? So you know what the area would be? Yeah, 9 times 3.14. 28.26. Okay. Moving on. So if it's x squared plus y squared equals 16, the area would be 16 pi. If it was x squared plus y squared equals 25, the area would be 25 pi. Really, really easy. I'll give you a second to try this one on your own. Write the standard equation of a circle that has a center at -4, 0, and it has a radius of 7.1. Here's the actual circle. Has a center at -4, 0, and has a radius of 7.1. Give you a second to try it. Okay, help me out, Zoe. X squared plus y squared equals r squared, but it's been moved, hasn't it? It's been moved left 4 units. So instead of x squared, it's going to be x what? Careful, moves left, it's opposite. So instead of -4, x plus 4. It hasn't been moved up or down any, so you leave the y squared alone, and Zoe, you do 7.1 squared for me. I think it's 50. .41. Done. So the equation of the circle would be x plus 4 squared, because it's moved left 4, plus y squared, because it didn't get moved up or down any, equals r squared, which is 7.1 squared, which is 50.41. Says the point 1, 2 is on a circle whose center is 5, -1. Write the equation of the circle. Gives you a center, that's great. Here's your basic form, x squared plus y squared equals r squared. I'm going to say it about 1,000 times so it just sticks. Again, that's Pythagorean theorem. A squared plus b squared equals c squared. X squared plus y squared equals r squared. Anytime you see Pythagorean theorem, instead of trying to think right triangles all the time, start thinking circles too. 1, 2 is on the circle. The center is 5, -1. Well, we can use this. If the center is 5, -1, somebody help me with this. X minus 5, and y. Hey, we're nearly done, right? But we don't have a radius. I believe, if I'm not mistaken, the radius is the distance. Does everybody hear that word? The radius is the distance from the center of a circle to the circle. It's the distance halfway across the circle. So if we're given the center is at the point 5, -1, and we're given that 1, 2 is a point somewhere on that circle. How do we find the radius? Try to hear that word right. The radius is the distance between the center and a point on the circle. What'd you do for homework? Distance formula, right? So now, do we have to use distance formula? No, we could actually use Pythagorean theorem if you wanted to. The distance from 5 to 1 is 4. The distance from -1 up to 2 is 3. A squared plus b squared equals c squared. You could also use your Pythagorean theorem. But let's just use distance formula. Just for extra practice, we didn't do a lot of distance formula the other day, so let's do it for practice. Distance, there we go. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. The whole reason I'm doing the distance formula, the distance from the center to a point on the circle is the radius. I need a radius. So we're finding the distance from here to here. Somebody help me with x2 minus x1. Actually, Sydney, help me with x2 minus x1. The second x minus the first x. What do you get, Sydney? 4. And if you want to go ahead and square it, that's fine. Help me, Carson, with y2 minus y1. y2 minus y1, you get?
-2.
There you go. Do I have to put the negative there? No. Because you're about to turn around and square it anyway, right? And it's going to do away with that negative. So you get the square root of 16 plus 9, which is the square root of 25, or 5. The distance between those 2 points is 5. So what do I put right here? 5, 25. Those are tough. Those are hard problems. It says a bank of lights is arranged over a stage. Each light illuminates a circular area on the stage. I don't know how they would know this. Each light illuminates a circular area on the stage. A coordinate plane is used to arrange the lights using the corner of a stage as the origin. The equation, this, represents one of the disk of lights. First off, let's graph the disk of light. Again, for me, graphing, here's your corner of a stage. And if you're going to graph for me, I'm okay with y-axis, x-axis, as long as you can count. We want to graph x minus 13, y minus 4 squared. Rachel, what's the center of that circle? No, careful, center. It's been moved from 0, 0, it's been moved here and here. Good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4. The center of that circle is 13, 4. It's been moved to the right 13, it's been moved up 4, and it has a radius, anybody, of 4. 1, 2, 3, 4. Down, right, left, and 1, 2, 3, 4 up. So there's my disk of light. And again, you take out your circle tool, and there you go. Or your coin. Unfortunately, your coin's probably not going to be the right size. So there's the disk of light. It says 3 actors are located as follows. Henry is at 11.4. Wasn't this 13.4? Henry is at 11.4, point H. Jolene is at 8.5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. There's Jolene. And Martin is at 15.5. This was 11.4, 12, 13, 14, 15, 5. There's Martin. Which actors are in the disk of light? Henry, and only Henry. Okay. Any questions on that problem? A cell phone network uses towers to transmit calls. Very similar. Okay, this is real life stuff. Each tower transmits a circular area, which we already know that. Okay, if we've got a cell phone tower and it's going to transmit 10 miles in all directions. There is a circular, okay, there's a circular collection of points that tells us within what region will these cell phone towers transmit. So it says each tower transmits a circular area on a grid of a city. The coordinates of the locations and radius of each tower are as follows. Tower A at 0, 0 covers 3 miles. Tower B at 5, 3 covers 2.5 miles. Tower C, 2, 5 covers 2 miles. Write equations that represents the transmission boundaries for the towers and graph each equation. I already done the graphs for you, I believe. Hold up a little bigger. Again, it says, let's go through these. Tower A is at 0, 0. Here's your first tower and transmits 3 miles. Tower B is at 5'3" and transmits 2.5 miles, 2.5 boxes in all directions. And then tower C is at 2'5" and transmits 2-mile radius. So let's go through and let's do these real fast. Okay? Your normal equation, x squared plus y squared equals r squared. Let's start with this one. It's got that same x squared plus y squared for the reason of it's not been moved. Its middle is the origin. What's it going to equal? X squared plus y squared equals 9. The radius, take the radius, which is 3 and squared. The green one has been moved. It's been moved right 2, it's been moved up 5. In order to move it right 2, we're going to have to do x. And in order to move it up 5, we're going to have to do y minus 5 squared. Perfect. Everybody catching on, right? It has a radius of 2 miles, I guess. 2 miles, so it's going to equal 4. And then you've got your blue one. Now this is a little bit uglier because it has a radius of 2.5 miles, but it still works the same way. It's been moved right 5 and up 3. Right 5 up 3, so x minus 5, y equals, and since 2.5 is the radius, 6.25. If you do 2.5 times 2.5, you'll get 6.25. There's your 3 equations. Second part tells us, tell which towers, if any, transmits to the point 1, 1. So was this tower, was this A? Let's see which is which. Tower B is at 5'3", and Tower C. There's how they are. So the point 1, 1 would be Tower A's transmission. The point 4, 2 would be Tower C's transmission. The point 3.5, 4.5, 3.5, 1, 2, 3, 4.5 actually gets covered by B and C. And then 2, 2.8, go over 2, go over 1, 2.8. That's probably my house. And then 1, 6 is covered by B. So yeah, that's most of our houses right there. It gets covered by absolutely no cell phone towers. You don't have any service.